Welcome, Algebra 2. Let's take a look at what you're going to start with today. So, you and your partners, you're going to take about, 10 minutes or so, and you're going to do a little matching activity with what you know about vertical and horizontal asymptotes. So, vertical asymptotes, when the denominator equals 0 and doesn't cancel. If it does cancel, then you get a hole in the graph. Horizontal asymptotes, Bobo Botan eats DC, bigger on bottom 0, bigger on top none, eats DC, exponents are the same, you divide the coefficients. So what you get are a series of graphs and you get a series of equations. And you're supposed to match it then with the correct description. So somewhere there's a graph, you would match the graph with the correct description. Or you would match the equation with the correct description. So there should be a pair, right? Equation with description or graph with description. But there will be no triples, no three of a kinds. Do your best to match. Pause your notes, come on back in a few minutes when you guys are done with that. And it will be quiz time. Yes, you may use your notes on your quiz. All right, so now that you're done with your quiz, let's take a look at Chapter 7, Section 4. We are adding or subtracting rational expressions. Rational expressions being things with fractions. So, in your notes, adding, you could use a plus sign, or subtracting, you could use a minus sign. Rational expressions. Like this one, 5 over 9x plus 3 over 9x. Well, when you add fractions or subtract, you have to have a common denominator. So are your denominators the same? All right, cool. So we can simply add the numerators then. 5 plus 3 gives me 8 over 9x. Once you have a common denominator, you leave the bottom alone, and you simply work with the tops. Do we have a common denominator? Well, denominator is x minus 5, denominator is x minus 5, so you have that same factor for each of them. We leave the denominator alone. It is still x minus 5. I don't know why, but sometimes it writes, I must like bump it or something. I don't know. There we go, that's better. And then we work with the numerator. 4x minus 3. Not like terms, I cannot combine them. That's done. All right, give it your best shot. See if you can add 2x squared over x squared plus 1 plus 2 over x squared plus 1. Pause your notes, work it out. You can check them when I come back. All right, I'll look for you. Welcome back. Common denominator is x squared plus 1. So we would simply work with the numerator. 2x squared plus 2. Did you get that? If so, you did good so far. Ha ha ha! There's more, of course, right? What I notice is that 2x squared plus 2, they each have a 2. So I could factor that out. If I divide by 2 and divide by 2, I'm left with x squared plus 1. Well, now that I have x squared plus 1 and I have x squared plus 1, right, I'm allowed to cancel the entire factor with the entire factor. My final answer would simply be 2. Why didn't we do it here? Nothing in common. Why didn't we do it here? Doesn't factor. Nothing in common. All right, so you're going to have to check and see, can I factor and cancel when I'm done? You and your group, how about you spend about 10 to 15 minutes working on adding and subtracting rational expressions part 1. That will give you ones that have a common denominator. And when we get back from our notes, we'll take care of not a common denominator. Aha, different denominators. So pause, come on back when you and your groups are done. Welcome back. The other thing we're looking at today is what do you do when you have different denominators? These are clearly not the same. So, what do you think we do? Well, yeah, you get a common denominator. Let's take a look at a simpler one before we do this. Let's say we have 1/2 plus 2/3. Denominators are different. So how do you get a common denominator? Well, we can multiply the two. 2 times 3 would be 6. So they're both out of 6. And I think, what did I multiply 2 by to get 6? Well, I multiplied by 3. Then I need to multiply my numerator by 3. So 1 times 3 would be 3 out of 6. What do I multiply the 3 by to get 6? Well, that'd be times the 2. So I multiply the top by 2. 2 times 2 would be 4. And if I now look, I have a common denominator of 6. Leave that alone. Add the 2 numerators, so you get 7 out of 6. So the first step is getting that common denominator. And one way to do it is to multiply each of the factors that's unique times the other. So if we can do that with numerical fractions, we can do it with algebraic fractions, rational expressions. We'll take our 7x times our 2x squared plus 2x and see what we can do. Well, let's go ahead and multiply by what's missing. This times this will be our new denominator. So we have 7x times 2x squared plus 2x. That's our new common denominator. So each fraction will have that new common denominator. Our first fraction had a 5, right? Had the 5. And it had the 7x, right? It was 5 over 7x. So what's the new part for this first fraction? Well, it's the 2x squared plus 2x. Here's a quick little check. If you have that over itself and it canceled out, would you be back to where you started from? Would you be back to 5 over 7x? Yeah. Let's take a look at our second fraction. We had an x, and we had the 2x squared plus 2x, right? X over 2x squared plus 2x. So what's the new part here? Well, that's the 7x. So we're going to multiply by 7x. If I cover up the 7x's, am I back to where I started from with that fraction? Then you know you're doing it right. Now the fun part. Everything's going to go over one common denominator. So there's our common denominator, and we'll start simplifying the top as we go. 5 times 2x squared, well, that'd be 10x squared. 5 times 2x, that'd be 10x. So here's my first numerator. Then what are we doing? We're adding, there's a plus sign there. What do we have here? We have x times 7x, that would be 7x squared. All right, what do you think you do next? Yeah, like terms. So, working with the numerator, we'll figure out our like terms now. Like terms are when you have the same variable and the same exponent. So 10x squared plus 7x squared. 10x squared plus 7x squared would be 17x squared. That takes care of that now. What's left? Plus 10x. Now, you might be thinking, am I done? Well, yes and no. That's a good start. We have to look and see, is there anything that can factor and cancel, right? Well, if I look at the numerator, 17x squared plus 10x, they both have an x. So let's factor out an x. If I take an x out of x squared, that leaves me 17x. If I take the x out of the 10x, it leaves me a 10. On the bottom, we got 7x times 2x squared plus 2x. Have an x on top, have an x on the bottom. They can cancel. I'm left with 17x plus 10 over 7 times 2x squared plus 2x. And yes, I could factor those parentheses at the bottom a little bit more if you were thinking, wow, 2x squared plus 2x, they have something in common. You're absolutely right. So, let's rewrite that and see what we can do with it. Got a 7. And we've got 2x squared plus 2x. So they both have a 2, they both have an x. They both have a 2, they both have an x. Let's factor out a 2x from here, a 2x from here. X plus 1. 2x times x, 2x squared. 2x times 1, 2x. Numerator, I think I was supposed to not have an x here. Numerator, nothing in common. Nothing I can factor up top. No twins down below with the top. So my final answer, 7 times 2x would be 14x. X plus 1, there's the denominator. Numerator, 17x plus 10. Welcome to Algebra 2, right? These get to be fun. We're way beyond problems that you can do in one line or with one press of a calculator. Now they might take a little bit of time. How about a quick little brain break? What do you call 3.14% of all sailors? They're pirates. Pirates are. Get it? Pie, sailors, get it? Get it? Ah, there you go. Okay, you got it. Who was the round knight's name, or what was the round knight's name who ate too much pie? The round knight's name. Well, that's circumference, of course. Get it? Sir Lancelot, circumference, get it? Nice, like of the round table? Okay, never mind. How about instead, you give that your best shot? You might want to, you know, factor, find your common denominator. Pause your notes, give it your best shot. I'll wait for you. Welcome back. So my first fraction, I think what I'm going to do is I'm going to go ahead and factor that 2 out and see what's left. And my second fraction, let's see, I'm going to factor x squared minus 9. That would be x plus 3, x minus 3. You have that difference of 2 perfect squares. Why did I do that? Because if I go ahead and I multiply this times this, I can get a common denominator. But what I noticed is we have a common factor of x minus 3. So they already have that in common. I don't need to repeat it if they already have it in common. When I'm making my common denominator, I want each of the factors that's different. So what do I need? Well, I need a 2. I need an x minus 3. I already have an x minus 3, but I do need an x plus 3. So the 3 factors that I need to make that common denominator are 2 times x minus 3 times x plus 3. I don't need another one. It's already in common. When it's in common, they both have it. That's what it means to be in common. So my common denominator will be 2 times x minus 3 times x plus 3. Let's see a plus in between them. Okay. 2 times x minus 3 times x plus 3. There's our common denominator. Let's look at our first fraction. We had a 5. This one had an x. And what was the new piece? Well, I had the 5, I had the 2, I had the x minus 3. The new piece is right here. It's the x plus 3. So if I put a new piece on the bottom, I have to put the new piece also on the top. I'm multiplying the bottom by x plus 3. I have to multiply the top by x plus 3. Let's look at our second fraction. We already had the x, didn't have the 2, so I need the 2. That's new. I had the x plus 3 and the x minus 3. I have the x plus 3, I have the x minus 3. So the only thing new for this one is the 2. Everything else was there. And if you covered up your 2 2's, 2 ballerina, you cover up your 2 2's, you'll see it's the same thing you started with. It's okay that it's x plus 3, x minus 3 are backwards. Same thing. When you multiply, 2 times 3 is the same thing as 3 times 2. You can switch the order when you multiply. We have a common denominator. We'll leave the common denominator alone for now. X minus 3, x plus 3. Okay, and let's work on our numerators. Multiplying using our distributive property as we go. 5 times x is 5x. 5 times 3 is 15. Plus, because this is a plus. And then we have 2 times x, that'd be 2x. Do you have any common denominator, or not common denominator, do you have any common like terms, I should say, like terms? I couldn't find the right word. You know, I knew what I was thinking, I couldn't find the right word. Like terms. Well, 2x and 5x are like terms. So how much is 2x and 5x? That'd be 7x plus 15 all over my common denominator, 2 times x minus 3, x plus 3. Does 7 and 15 have any common factors? Like, is 15 7 times anything? Not a whole number, it's not, no. 3 times 5, right? So nothing in common, nothing will cancel, that's done. There's our answer. You and your group, give it your best shot. You are trying, you're trying part 2. Adding and subtracting rational expressions. Watch that sign in the middle. In case it's ever a minus, you're gonna have to pay attention to what that sign is. You're also going to have to make sure to get a common denominator. Factor your denominators first, see what's needed, right? Good luck. Give it your best shot. See you guys next time.